I just recall while teaching you guys, and I hope that helps you guys when you talk about it. Now you can use it. I hope there is no question. So we talked about distance, we talked about volume, we talked about weight in both the units, both the systems actually. And we looked at what is the conversion and how do we deal with the conversion without relying on that conversion formula being given to us. Yeah? Okay. Shall we move on?
Yes, sir.
Okay. Now the next topic that Pranit had given was radical and rational exponents, expressions and equations. So expressions and equations we dealt with in the previous class. So radical and rational exponents. This is what we are going to talk about. Do you guys remember what exactly it is? What is radical and rational exponents? What is the difference between the two? Are they same? Are they different?
They're basically the same thing, but they're written differently.
They are written differently or represented differently. Okay, now let me bother you guys with few problems to see how comfortable are you with rational exponents. And again, this is not to get you worried, but to bring that element of playfulness. Now, if I ask you guys to solve a problem, okay, before I start teaching something, I want to check how comfortable you guys are, and then I will teach. 9 to the power 1 by 2 multiplied by 16 to the power 2 by 4 and let's say 3 by 2 divided by 3 to the power minus 6, or let's not make it very big, 3 to the power minus 2. Can you guys solve it and tell me how much it will be? This is a classic case of rational exponent, where your exponent is like a rational number. That's why it is called rational exponent. So, do you guys want to try solving it, or you would rely on me for helping you recall? It's okay, I mean, any which way is okay. Who all is trying this? 9 to the power 1 by 2 multiplied by 16 to the power 3 by 2 divided by 3 to the power minus 2. Is somebody trying? Not trying? You want me to try? Don't be shy. Okay, let me start putting you guys on the spot then. Ritika, are you trying?
Yes, sir.
Okay. So, Heel, Arya.
Yes, sir, I'm trying.
Okay, okay. Yeah, I just wanted to hear that so that I don't wait in anticipation, okay?
Do you want the answer like a whole number, or do you want us to just say it in exponents?
Simplify as much as you can.
Okay.
And this is a playful part of math, okay? This is not serious math. This is a playful part, okay? Try this. I mean, I'll bring the fun into it, okay? Okay. Yeah, Ritika.
I just got the answer.
How much is it?
I'll say it as the simplified version. 3 cubed times 2 to the power of 6.
3 cube
Times 2 to the power of 6.
Okay, we'll see. And all my students, they hate me for one statement. I say I don't trust you. I don't trust anybody when it comes to math. I trust everybody as a person, but I don't trust anybody when it comes to math. That means I will do it myself. And the message to each one of you is, even if you hear a question, answer of a question, don't get biased. That's where that I don't trust anybody comes into play. You will say, okay, fine, let me check and review my own answer as well to see if this is correct or not. So while everybody else is doing, I am giving you guys 5 minutes. While everybody else is doing, Ritika, if you want to review what you said, if that you think that is written in stone, wonderful. If there is an opportunity for correcting it, you can do it in parallel. Sally, you are trying as well, beta?
Yeah.
Okay. I mean, I want everybody to try it today. Because when you try, you will know how far you're able to go and where you are getting stuck, if you are. Okay. So I'll just give another 2-3 minutes and then I'll probably start solving it. Aryan, are you able to hear me okay?
Yes, I just got disconnected.
Yeah, that's why I was asking if there's any network issue at your end. Okay. But you got the question right, Aryan?
No.
The question is we have to solve this one and get a simplified answer for this. 9 to the power 1 by 2 multiplied by 16 to the power 3 by 2 divided by 3 to the power minus 2. Okay. So yeah. Sorry.
Sir, I got the answer, but I did that in my mind, so is it okay?
That's fine. Tell me the answer.
It's 3 cubed times 2 to the power of 3 by 8.
Okay. So while it is advised that you can do mind math to do things quickly, but I'm an old school guy. I always recommend or prescribe everybody to practice doing it. Okay, because when you do it, then you would know how you did and where, if you went wrong, where you went wrong. Okay? I mean, not for this question in particular, I'm saying, but make that as a habit of doing it. You would see that when I do solve problems, I I try doing each and every step, in a as simple way as possible, and that actually helps me review things. Okay, so uh, get into the habit of doing problems by solving it, because it brings more speed in your calculation approach as well. Okay, alright, so I think we have done enough talking. I trust you all can do it, but let me give you guys a very simple version of how to solve this kind of problem. And whoever has done it can probably just use my next 5 minutes of the solution to review the answer. Now, this is using the the three basic rules of exponents that we all have learned. One is called x to the power a multiplied by x to the power b equals x to the power a plus b. I hope you all know this, and if there is any doubt, you can ask me why, and I can prove that as well. Now, second rule says x to the power a divided by x to the power b equals x to the power a minus b. Okay. Third rule says x to the power a in bracket to the power b equals x to the power a times b. And there are three rules that you would have seen, that you would have learned, and that will be part of your muscle memory going forward. Like you all know, a plus b whole square equals a square plus b square plus 2ab, a minus b whole square equals a square minus 2ab plus b square, and a square minus b square equals a plus b into a minus b. Like these are some of the generic rules that we learn and that stays with us for much longer time, right? Similarly, for exponents, these are the three basic rules that you would have learned. Now, if you ask me why this, that also is easy to prove. I mean, let's say 3 times 3 times 3 is 3 to the power 3. That's what it is. Now, if I say 3 square into 3 to the power 4, what exactly it will be? 3 square will be 3 into 3, and 3 to the power 4 will be 4 times 3. What happened? It became 3 to the power 6. 2 plus 4. Similarly, you can check the division thing also as well as this power 1. Now let's come back to the question that we were trying to solve. This says 9 squared. 9 I will put inside the bracket. 9 to the power 1 by 2. I'm putting 9 inside the bracket. I have not done any calculation. I'm just organizing myself. Okay. Divided by 3 to the power minus 2. Now 9 to the power 1 by 2. I can write 9 as 3 squared. As I said, we want to get a simplified form of this. So that's why I'm trying to break it down to smallest possible numbers so that our life gets much easier. Now 16. 16 also I can, this is also a square. I can write this as 4 to the power 2. Okay. By 3 to the power minus 2. Now you look back at this formula. The third formula of exponents says x to the power a to the power b equals x to the power a times b. Look at this, x to the power a to the power b equals x to the power a times b. This one is done. Then again x to the power a to the power b, it becomes 4 to the power 2 3 by 2 by 3 to the power minus 2. I'm not dealing with this guy for now. Let me deal with the complex things. Now comes the tic-tac-toe in play. I call it tic-tac-toe, where you keep crossing things which are matching. This 2 and this 2, you can do tic-tac-toe. This 2 and this 2, you can do tic-tac-toe. What we are left with? 3 to the power 1 multiplied by 4 to the power 3. 2 into 1. Now you have 3 to the power minus 2. So this became 3 into 4 to the power 3 divided by 3 to the power minus 2. Now this 3 to the power minus 2 here and this 3 here. We have two options. We can get this guy here or get this guy here. And when you move something from denominator to numerator, the power inverses. So minus 2 will become plus 2. So this becomes 3 into 3 to the power 2 multiplied by 4 to the power 3. That means you have 2, 3. So this becomes 3 to the power 1 plus 2, 3 into, I am squeezing in this corner here. So here I have 3 into 3 square. That becomes 3 cube multiplied by 4 to the power 3. That is 4 cube. You can write it like this, or you can say, oh, this is both are power 3. So I can write this as 3 into 4 to the power 3, 12 to the power 3. So if you look at what I did, trust me, I did nothing. When I say nothing, I did not do any big calculation. I just simplified the problem. I had 9 to the power 1 by 2. But just by looking at 9, I can see that 9 is nothing but 3 square. I had 16. 16 is also nothing but 4 square. So I said, okay, fine. I can use this formula. I just converted this to a square, and this is what I got. And then I applied this formula, x to the power a to the power b. Simple. What it became? Very simple. While I tried to scare you guys by giving something complicated like this, but when you try doing it, it's not complicated. Right? So, first of all, before I keep bragging about what I did, were you guys able to follow what I was trying to do here?
Yes, sir.
Everybody understood? Now, whoever did not get the same answer or similar answer, probably there is something that we missed, something we overlooked, something that we did not apply well according to the basic rule of exponents. Yeah.
Yes, sir.
So, was this a tough question? No. Did we make it tough? Probably yes. If we did not get the right answer. Okay? So let's get to the habit of taking the responsibility for making simple things complicated. Okay? It is us. We as individual, we make things look complicated. Okay? Always assume that okay, there is a question that can be solved. That is only me. That's the key of my tran that I keep talking about. Yep. Alright? Everybody with me so far?
Yes, sir.
Yes, please.
Okay. So let me check with the new student. Shali, were you able to follow what I did?
Yeah, yes, sir.
Easy to understand?
Yeah.
See, that's why I keep saying I'm the best teacher. I'm just kidding. I'm just kidding, okay? I don't think I'm anywhere close to being the best teacher, but yeah. I try making it simple to become a good student, okay? If I'm a good student, at least I'll be able to resonate well with you guys, okay? Now, let me show you guys something interesting, okay? Since we're talking about exponents, can somebody tell me what is the value of this, 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 and this? There are four options. X to the power 0, 1000 to the power 0, a million to 100,000 to the power 0, and 0 to the power 0. Everything is 1. Everything is 1. 100% sure? No?
Sir, x to the power of 0 is 1,
Okay.
and then 1000 to the power of 0 is 1,
Okay.
then 10,000 to the power of 0 is 1,
Okay.
and 0 to the power of 0 is 0.
Yeah. That's the only thing. 0 is such a powerful and useless number at the same time. Add 0 to a number, magic happens. Deal with 0 alone, no use. Now, the $1 million question here is why? You said x to the power 0 is 1. Okay, why? Can you prove it? Can anyone tell me why x to the power 0 is 1 or 1000 to the power 0 is 1? Ritika, that's a challenge for you. Here, Aryan, everybody. And let me tell you guys a funny story, okay? This question had come to me. One of my students asked me, you said x to the power 0 is 1. But why? And I keep telling that, no, don't trust anybody. If I'm saying x to the power 0, 1, you ask me why. And unless I prove that, I'm not holding any water actually. Right? So anything that I teach you guys, you have all reasons to ask me why. So now since you guys are telling x to the power 0 is 1, now I'm asking you a reverse question, why? Can you prove it? And this is a creative question, okay? This is not a tough question, it's a creative question. And trust me, when I try proving it, you will say, yes, I knew it. Here, Ritika, Arya, Nanya, anybody, you guys are being very shy. Yep. Aryan probably knows it. Were you in the class?
This is kind of like a guess. It's more of common logic. But if something is to the power of 0, it's not multiplying by 1 or by itself at all because to the power of 0 is basically doing nothing. So instead we would inverse it and divide it by itself to get 1.
I think you said it conceptually right, but since we have only 5 minutes, I will prove it mathematically. Is everybody wanting to wait to see that?
Yes, sir.
Okay, let's do it. And the clue is exponent tells us that. Now you look at this. If I say 3 to the power 0 is 1. Okay? I just said so. But how? Now, 0 is what? I can say 3 to the power 0 as in 3 to the power 1 minus 1 or 2 minus 2. I can do that, right? Now, let's do 2 minus 2 minus 2. 2 minus 2 makes it 0. Okay? Sit down. So, that means x to the power a minus b. Second rule of exponent says x to the power a divided by x to the power b equals x to the power a minus b. This is what we have, x to the power a minus b. A and b both are same. This will become 3 to the power 2 divided by 3 to the power 2. Yeah? That means 3 to the power 2 is 3 into 3 divided by 3 into 3. You do tic tac toe. You're done. This is done, this is done. 1. Now you can choose 3 to the power 0 as in or x to the power 0 as in x to the power 4 minus 4. That is also 0. Use the second rule of exponent. Put that value. You get 1. So hereafter, if anybody says x to the power 0 is 1 or anything to the power 0 is 1 except 0 itself, why it is the case, we just saw it happening. Yeah? Correct? No reaction. Okay. Alright. Okay, there is one child missing in the class. That is Sunarka. That's what I was wondering. Who is not here in the class? Okay, so now we are almost top of the hour. We have just 2 more minutes. So I'll tell you guys something interesting about it. And I was in a doing there was some festival at home. I was in the temple and doing pujas because this one of the child had asked this question how this is the case. I was thinking, how do I prove this? I was doing puja actually with my wife, and then all of a sudden I was just wondering, how do I prove this? If I cannot prove it, my kids will think that okay, my teacher doesn't know anything. And then all of a sudden this clicked. So I'm not saying it's because of puja. What I'm saying is you get ideas when you think about it. We all know concepts, we all know formula, we all know the way those are derived.